Let us now look into linear inequalities graph. So I'll show you how to represent linear inequality on the Cartesian plane. So I'm actually moving on from number line to Cartesian plane, since now I have equations with two variables. So you see here we have two equations, and these are the two examples which we are going to do in this video. So the first one is y is greater than x, and the second one is y is less than equal to 2 over 3x minus 4. So both of them are inequalities. They don't have just an equal to sign in between, but they have inequality signs greater than in the first case and less than equal to in the second case. So let's start with a simple one, which is y is greater than x, right? So I'm not using a graph paper to graph it, but I'll just show you kind of a sketch, and I hope this teaches you how to sketch neat graphs for inequalities, right? So these are my two coordinate planes. So this is the first one for y greater than x. So y greater than x, how should you understand this inequality? It really means that y is, if you consider the line y equals to x, that means y is not equal to x, but y is greater than x. This is how you should look into it. So y is not equal to x, but y is greater than x. That is what we're trying to graph. So y greater than x normally is a solid line. So you can draw this. This has got x and y intercept at origin. If x is 0, y is 0, right? And you know the slope is 1. So if you go 1 up, you go 1 right, 2 up, 2 right, right? Similarly, if you go 1 to the left, 1 left. So that is the line being represented by y equals to x. Now when we are saying y is greater than x, then what we do is we draw a dotted line for y equal to x. Since we know for our inequality y is not equal to x, but that forms a boundary line. Do you understand? So what we will do here is we will draw a dotted line. And this dotted line is actually the line for y equals to x. Okay, this dotted line is y equals to x. But what we want is y is greater than x, not equal to x. So of course, greater than x will mean greater than x or above the line. Do you see that? Everything above the line should be greater than x, right? So the y values we are looking for, which should be more than the y values represented by y equals to x. So the graph which I have shown shading upwards from the line, not including the line, is y greater than x. Do you understand? That is how you show on a Cartesian plane or a coordinate plane y greater than x inequality. Now what you can do is you can test for some point, right? So let us say we have a point here, and this point is 0 for x, and let us say 5 for y. In that case, if I put 5 here and 0 here, my inequality is satisfied, right? 5 is greater than 0, correct? So that is one test point. You can also consider one more test point, let's say on the other side, where you are not graphing. Let us say this point is minus 5. Now if I put minus 5, so the coordinates for this point are actually 0 for x and minus 5 for y, correct? Now if I put minus 5 here, then minus 5 is not greater than 0. Therefore, this is not in that portion which we have shaded, correct? So it is on the other side of y greater than x. That is what we're trying to say, correct? So that is how you can test with few points on the coordinate plane, right? So our test clearly indicates that y greater than x will be on the upper side or pointing above the line y equals to x, correct? So as a general rule, if we keep y isolated on the left side and write all of the things on the right side, like we do in slope-intercept form of the equation, then greater than will mean arrows pointing upwards from the line. And less than will mean arrows pointing downwards from the line. So that is kind of a rule which you can follow. Second thing what you should notice here is that when we say greater than, then the line is not included. But if we use greater than equal to or less than equal to, then you have to include the line, which brings us to the next example, right? So we've done the first one. Now let's look into the next example. It says y is less than equals to 2 over 3x minus 4. So let's see this equation in two parts. That means it is saying that y is less than 2 over 3x minus 4 and y is also equal to 2 over 3x minus 4. It really means this, that is y is less than 2 over 3x minus 4 or equal to. So it is less than or equal to, correct? So both cases are being considered in this equation. So we should have a solid line to represent y equals to 2 over 3x minus 4, and arrows should point downwards from that solid line to show y is less than 2 over 3x minus 4. I hope you get the point, right? So let's sketch this line. By now you are an expert to sketch lines given in slope-intercept form. Here y-intercept is minus 4. So let's say 1, 2, 3, 4. So that is my y-intercept, minus 4. Now slope is 2 over 3. That means you go up by 2, 1, 2, and 3 is 1, 2, 3 right. So you get the next point. Then again you can go 2 up and 3, 1, 2, 3, right? So you get another point. Joining these points, we get our line y equals to 2 over 3x, right? Let's join them. So the line represents y equals to 2 over 3x minus 4. Now we have to also include y less than 2 over 3x minus 4. That means all values of y which are less than these values of y. So values of y less than these will be downwards, correct? So we can shade downwards from here, and that represents our inequality y less than equals to 2 over 3x minus 4. Do you understand? That is all. So what you need to do is just do what I have shown here and get your graph, right? At the most, you can just label your graphs and just show your scale, right? So in this case, the scale is 1, 1, minus 1. This is minus 1, and that is plus 1, correct? And that is how you can just sketch your lines and shade. While in school and examinations, you will be provided with graph papers. So use graph papers, rulers, and set squares to draw neat graphs. If not provided, you don't really have to have those graph papers. You can do as I did, and this is good enough. Let's take some more examples and understand how to do linear inequalities when given such equations. Thank you.